that this committee has been interested in is how we're going about our state of the environment monitoring, and Mike's here to give you a great update on that. And if that triggers thoughts about reports or information you'd like at future committees, please feed that through Katarina so we can give Mike and the team plenty of time to prepare. So over to you, Mike.
Thanks, Brett. Thank you, Chair. On the front here, I've just got a picture out of our State of the Environment report. Any councillors who haven't read that, do urge you to go and have a look at it. It gives you a really good summary of where some of those significant issues are. And as Brent said, this committee has been fundamentally important in both, I guess, the reporting process to governors on the state of the environment, but also the response that council developed when that state of the environment report came out. So this committee was critical to that, and hope that will continue into the future. So I've just got 4 slides, I think, and probably a good thing Councillor Smith isn't here because the text is a bit small on there and you can't necessarily read it very well. But on my screen, it looks pretty good.
Yeah, my screen looks marvellous.
So I'll take the report as read, and as I say, there's layers of detail. The next layer of detail is in the State of the Environment report itself. I'll just mention I've got Jonathan Caldwell here, one of our most senior scientists, is here as well. His expertise is in environmental chemistry and emerging contaminants, so he can deal with tricky questions as well on those topics. And Jonathan also leads our State of the Environment reporting project. When we look across the whole region, just in very summary terms, water quality for recreation, so that's contact recreation, swimming, boating, etc., tends to be quite good at the coast, except when it rains, and around Lake Taupo, except when we do get occasional blooms in the lake. But for many of most of our smaller waterways throughout the region, they don't meet swimming water quality guidelines, primarily because of levels of E. coli. Some of our Waikato River sites are quite high quality in terms of swimming, so they meet swimming water quality guidelines most of the time. But we have seen these emerging trends of algal blooms in the hydro lakes over the last few summers, which is causing significant concern and impact. Another highlight is that most of our lowland lakes within the region are degraded, so that they have high sediment levels, high nutrient levels, and they're often dominated by invasive species, though many of them have lost their native vegetation and are now dominated by algae and the invasive species, such as koi carp. We're seeing less phosphorus and more nitrogen in our waterways, so this is a general trend. Obviously, there's some pluses and minuses in there, but that tends to be consistent with our pictures about land use intensification and also improving land use management. So we're seeing nitrogen signals in many of our waterways which reflect past land use intensification. We're also seeing improvements in phosphorus which link to improving point source discharges, but also improving land management practices. Lake Taupo remains in good health. In the early 2000s, there was real concern about the health of that taonga lake, and Waikato Regional Council, along with the local community and central government, put in place measures to protect that lake, and those measures have worked, and we're really pleased that the signals we're seeing are of the lake improving more quickly than we first thought. Right across the region, primarily because of the level of human activity across the region, many of our terrestrial freshwater and marine ecosystems are under increasing pressure. We're seeing soil quality improving overall, but there are issues, particularly in some areas, around erosion, peat subsidence, and compaction. So there is still some issues around around soil quality, but across the region as a whole, it's improving. We're seeing water security challenges, and this continues to be a area of particular effort for us. We've seen reductions in rainfall over decades, and our demand continues to increase, which puts us in a water security challenge. And this is Jonathan's area of expertise. Overall, air quality is improving in most towns, but we still see some airsheds breaching guidelines, particularly places like Tokoroa, where there's a lot of wood fire, wood burners, which contribute along with the climate in Tokoroa. Sorry. There's a whole range of emerging environmental issues. So that's one of the things the science team spends quite a bit of time on, is trying to understand what some of these emerging issues are and how it might affect the region. So from Upper Waikato River perspective, we're seeing some quite worrying signals around increasing frequency of algal blooms. We saw some pulses of arsenic coming from the hydro lakes down the river, and the golden clam spread is changing the river ecosystem. So those are some quite worrying trends. We've for quite some time had concerns about the Firth of Thames and the levels of sediment and nutrients in the Firth of Thames, and the potential for it to cross a tipping point, if you like, and become a much more eutrophied or nutrient-rich environment, where we might start to see issues with oxygen depletion in the bed of the Firth. Emissions from drained peat are a major contributor to our regional greenhouse gas inventory, and the council's seen quite a bit on that. And a big question for science is, how do we mitigate those losses while maintaining productivity of those lands? We're seeing emerging geothermal technologies, and obviously the government's developed their geothermal strategy. This region has a large proportion of the country's geothermal energy resources, so that's something the council is going to need to consider more in future. This is quite a new one. There's an emerging evidence of microplastics in the environment, and on a national scale, some work done to show that some Hamilton streams particularly had higher levels of microplastics than other parts of the country. We've just hired a new scientist in the contaminated land team who has specialty in microplastics. So they started yesterday. A changing climate is putting more pressure on the environment, as we're probably all well aware. And we're seeing increasing impacts from invasive plant and animal species, which are probably, as part of the changing climate, really enjoying being in the Waikato and making the most of it. I'll just go through the last couple of slides, which is thinking about topics for... Are you ready? Is that right, Councillor? Yeah.
You can wait.
So topics for EPC agendas in the future. I know the Chair and Brent sort of get together and talk about suggested topics. I just thought it might be useful to provide some suggestions. One is around understanding our region's natural resources and the opportunities and constraints. So what is the ability, or where is their ability to grow as a region? What are some of the constraints? And water security would be one of the key ones to consider. But are there parts of the region where we should be considering growth? and other areas less so. Managing human health risks in the region is an important topic. Obviously, people want to be able to swim and recreate, and we've seen that from the Upper Waikato hydro lakes, the community concerns about the blue algal blooms stopping them being able to enjoy those waterways. The third one's around giving effect to Te Ture Whaimana. Apologies that I misspelled that, not Te Ture Whenua, but Te Ture Whaimana, or Te Awa o Waikato. So that's how do we as a council contribute towards giving effect. And I guess that's primarily from a science perspective, is what do we understand, what do we know about how that restoration of and protection of the river might need to happen. Soil health and management of soil risks. Obviously, much of our regional economy is based on healthy soils and sustainable soils, and so that's a significant topic. And managing quality and quantity of fresh water for multiple values. Often there's a real conflict between economic development and ecosystem health, and it's all tied up again with things like Te Ture Whaimana. The final few here, managing land use intensification. So that links probably to the first one I was talking about, is central government is talking about growing the economy from a regional council perspective where we're managing sustainable use of resources. How might that look in our region? An important one linking back to the Firth of Thames is improving our understanding of the connections between the land and the coast. And the science team has been doing some really cool work on the dynamics of the Waiho-Piako rivers and how those influence the Firth of Thames. So I think it'd be really good to put that in front of you sometime in the future. Obviously, changing climate is a big one, and what we could do is provide an overview of the sorts of things that we're seeing from the climate data and what that means in terms of the region's environment and resources. And a biggie, which would be feeding into the work Jonathan's leading, is around the design, delivery, and then the response to the next State of the Environment report. So again, hoping the EPC will continue to have a important input into that process. So thank you, Chair.
Thank you, Mike. A couple of questions for me anyway. First and foremost, is there, under the State of Environment, when there's been a big impact of a storm of some sort on the waterways, do we have any, how do we measure that particular impact on areas? As for instance, when you, in Waipa and Karakia, we've never had that before. So it's been for us to measure what it was to what it is today. Is that able to be done in
Yes.
some areas? I don't expect it everywhere.
Yeah.
But and then we look at, if you go over to Otorohanga across the Pūniu River, they took 2 or 3 years between Waikato Regional Council and Pūniu River Care. They're beautiful water plays in there, and the water didn't get to the bridge. So do we have measurements on the impacts of what good we have done and why we have done it, as well as what didn't we do and what would have happened if we did do, sort of thing?
Yeah.
Do we have something like that?
Yes. So I think that
under the State of Environment.
Yeah. In the State of the Environment program, and there's a connected program, we do riparian surveys every 5 years, and that information goes into the State of the Environment report. Just this summer, a team of some students with support from some of our scientists undertook a survey of the Kaniwhaniwha stream coming off Mount Pirongia, and they finished that work 2 weeks before the major flooding. So we're now looking at going back into that catchment, because we want to, the survey looked at stream fencing, riparian planting, bank erosion. And the whole purpose of that is to see, as over time, as fences are put up, plants are planted, and what happens to the stability of the banks and things. So an event like that gives us a great opportunity to say, so how much of the fencing was destroyed in that flood? How much of the riparian vegetation was wiped out? Because we often hear from farmers, I'd rather not fence that area because it's just going to get wiped out in the next flood. But we don't necessarily have good data on that, and this gives us that ability.
Good. Thank you, Mike. Okay, Robbie's the first person with a question.
Thank you,
Robbie,
Madam Chair.
Keith, and Jim.
Try and stick on topic.
That's because he moaned about the last person.
The big thing with the Waihau and the Piako and the Waitoa is knowing where that E. coli is coming from. And we've already talked about that in previous meetings. It's identifying where the subcatchments are that's coming from. Because there is a lot of other, sheep and beef and other land uses where if you're dairy, you're meant to have all your drains fenced off and protected now. So I'd like to know where is there subcatchments that are causing the issue, or is it just farming in general? So, and are we living with a legacy with contaminants in the catchment where we've all reduced using phosphate and nitrogen, and are we just dealing with those at the moment? Yet they're going to come down over time. So I'd like in the future, I'd like to understand, I don't know, on my farm, I'm using half the amount of nitrogen that I used to use on hardly, except for supplementary feeds, we're bringing hardly any phosphate into the farm at all. So where is that a figure that's been done by capital phosphate fertilizers 20 years ago, and we're just dealing with that, and sooner or later it's going to start dropping, does that make sense?
Yes. Yeah.
So I think that would be really good information. We've got to be able to sort of analyze that data and come up with something. Then we know what this catchment needs to be done to it without knowing the bottom lines at the start, because then we can say, well, if we want to get to this figure in 20 years' time, this is what we need to implement, if that makes any sense.
Yeah.
To get a downward trend. Or is that downward trend just going to start because everyone's using farm plants? Are we going to get there on their own? If that makes any sense?
Yeah.
Or where do we want to get to?
Yeah.
So I think that's really important with the settlement issue is really, it's the some of that settlement issue is how the river functions down the bottom there on its own natural way. They are both deepening. I think the Piako and the Waitoa at the bottom, Piako and the Waihau, they've gone about 3 to 4 meters deeper than what the original design was. It's just because the tidal function, how they work every day. So you only got, to tell you the truth, I don't know if you guys have been down there, but you need to go down to Shelley Beach Road, watch the tide come in one day at the new rationalisation project, and watch what happens when the water comes in, the tide, full tide, and the water comes back out again. And that's the settlement that's in solution 24/7 every day of the year. That's in the tidal action at the bottom. So I think we need to, if you actually go down there and see it, you'll see this water go in there. You can't believe it. It's just murky, dirty stuff. It gets to sit there for 20 minutes and all of a sudden the settlement falls out and it's actually quite clean water runs out of the bird sanctuary. It's amazing. So, yeah, I'd love to try and work out what's actually in solution. What's in solution from the way it operates to actually how much solution settlements coming down from other way. Does that make any sense?
Yeah, it does, absolutely. And I think that would be a really good topic, Chair, perhaps for a future EPC, because we are doing a lot of work, including modelling work on the, as you say, there's that part of the system where it's just really highly turbid because of the saltwater, freshwater interaction. We've got one of our senior scientists, Stephen Hunt, who does the sediment modelling. On the E. coli stuff, we're also doing some work in the Upper Waihau about E. coli sources because of issues around Blue Spring and that White's Road area. But yeah, I think it would be really useful to have a specific topic on that that Hauraki Plains catchment and the interactions with the Firth, because I think there is a lot of information that we could provide.
It'd be good to get some good data collected that we can go to the community and say, do you want to do some catchment restoration? You can make some real gains here. We could put a low targeted rate on the catchment and do some catchment restoration. That there would be greater benefit to the water and the whole catchment. I think that's something that we've got to look at, but I'd like the data to make that decision that that's going to be a good outcome. So that's why I kept asking those questions to get there. But the other thing is going back to energy generation, where I was with Shane Jones the other night, and they've got this idea at the moment. Well, it's hypothetical, but they can drill down about 5 k's and they can actually hit material in the ground that they can actually make geothermal energy immediately. Would that still contain same contaminants that you get down in down Taupo still come off that?
Yes.
And so that would be my point, that these geothermal contaminants could still become, if we go and do it sitting next to Auckland, we might have to deal with them somewhere else. That's just the point I was going to make.
I don't know, Jonathan, if you wanted to comment on geothermal.
Yeah, I mean, I'm not a geothermal scientist, but I am aware that there are issues around that. I mean, it is a very good source of energy to tap into, but there's at this stage there needs to be some more understanding around when you bring that material up to the surface. What are the impacts? Can we manage it? So I think definitely it's a source we would want to look at how we might be able to tap into, but we need to support that extra support to get that information around how we can manage it at surface.
Well, it's definitely an area that's going to put more pressure on the Waikato region to generate energy for Auckland. Is going to be put in our backyard. So I just thought I'd put it there.
So Rob, if I could just jump in there, it's called the Supercritical Project. Right now they're looking at doing a trial, and they're currently engaging with, so that's between Ngātamariki, and so they're currently engaging with this council around whether and what's the process for getting permissions to be able to exercise that trial. And the sort of thing that you're describing and Jonathan's describing are the sorts of things that we would feed in around wanting to gather the right information from a trial about what would it look like.
I don't disagree with it. I just don't want our community to have to then pay to clean it up. That's what I was meaning. It's
absolutely, which then lends it to getting the right information through any trial to be able to support any long-term decision making.
So we've been doing geothermal in the middle of the country for many years now, and they did start off that it wasn't good, but we've gotten better. They've gotten so much better. So what they take out, they use a very big percentage of it in power and every other thing that's going there. There's not as much waste as there used to be, and then they fill up. How do I know? I'm an owner there. Yeah, that's right. Yeah.
Through Chair, if I could just add to it. So Tim Grosser is ex-Minister of the Crown, ex-US ambassador, had a discussion with me recently. He is actually leading the project on behalf of the government. The government is going to spend $60 million in the first trial to actually find all this information out. They don't even know how they can drill down that deep and secure a bore to do it. They don't know what they're going to find when they bring it up to the surface. And it's it's $60 million in the first experimental site for it. If they found something of interest that they could do it, and they find something of interest, there's a long way to go with new experimental stuff before they can even start thinking about it. So I think that's the purpose of it, as I understand. And I think that what the contaminants are, what the very question you've asked, is probably the big unknown for them.
Okay, Robbie. Yep, Keith.
Thanks, Madam Chair. Just in your excuse me, in your presentation, Mike, first thing I would say to you is that we are proud of the work you do and the team, because some of us are really old and got white hair. I was actually looking at Ben, but I'm actually older than him. Can I remember swimming or doing raft races in the Waikato River, and we would have dead animals come past, we'd have car bodies, and we would have human feces and the stuff sticking out here and that sort of thing. So the situation was really, really bad. And I think that we should actually tell that story. We've come a long way. We've done a lot of good stuff, and you know, and that's a credit to what the regional council has done. So a lot of the focus at the moment is, you know, it's really bad out there, but we've actually done a lot of good, and I think we should tell that story. There's a couple of things I'd just like to raise, and it's I'm just a little bit concerned that we used Lake Taupo as a model of what we've achieved by stopping farming. But I've swum and I've sailed in Lake Taupo for many years, and it was always pristine because there was farming there. And so the little that you stopped is not really a good indication of what we can do in our other lakes and that sort of thing. So I think the comparison's a little bit unfair. Sure, we have to do better. And one of the things that I'm also concerned about, and somebody brought it up earlier, was the issue of nitrogen. We know that nitrogen has a legacy tracking, and certainly, like Mike and I have spoken about the trials done up at Wata Wata, we're finding nitrogen coming out of areas that we just don't understand. So I think we need a certain amount of honesty in the narrative that we're talking about. We're trying to do better, but some things we don't understand. And I'd always go back, we just still need good information and good science. What I would also add in there is, I don't think, and I think Mike's got a lot of data about that, we should underestimate the cost of warming of the area, we call it climate change or whatever, to the welfare of the water, because it's allowing the algae blooms to go. And I think we need to be honest with people about that. I think that's it's warm water creates a whole lot of other problems, and I think we need to be honest about that. The other thing, obviously, I wear a belief that we've got to have a strong economy. I think we actually need to have a visual set of scales there, or thing on the fulcrum. So if you want pristine water and pristine environment, there's a pressure on the economy, and I think the whole population in our region needs to be part of that. You want good hospitals, you want good roads, you want good education, and that sort of thing. It's got to be generated, and so at some stage there has to be a compromise. And I'm not saying compromise, a silly compromise, but I think we need to lead that discussion. If we don't lead that discussion, there's always going to be this polar pressure against, well, you know, defined as the greenies against the capitalists. But it's not like that. We actually need money to be able to do all the good things we want. And I think that picture needs to be out there. We're making good progress. We're making good gains, but there's a trade-off, and we need money in the economy as well.
Okay. There's no answer to that, by the sounds of it. You just need to have
I agree with Keith.
Yeah.
Absolutely.
Well, if you can pick out some things in there for next one, that'd be great. Yeah. Yeah. And go back. Yeah. Oh yeah. Oh no, not that. Jen.
Oh, well, if Mike's going to agree, I can disagree with some of it. I think I'm going to say that rather than the duality, there are lots of just where we can be flexible one of the concerns I've got is that, because I understand the argument needing to have money to be able to look after things, but there's the contrary side that when we have a state of the environment report that shows us that things are trending really poorly, noting, totally agree with you, Keith, on the point that we have done good things to improve our processes, but when there is growth in population, that might not be enough. So I think that I have a concern that we will not be able to make money when we have degraded the free source of raw materials to a degree that we're not working with. So that's why I have a really big interest in the environment. And I was amazed how little contact I actually had with it in the first few years of being a councillor. And I would love to see more of that last suggestion, the design, deliver and response next report, so that it doesn't come as much of a surprise to our council. I really like some of your other suggestions of what else we can have. I do think though, I've seen this presentation in a different format at the end of last training, and I remember the committee said we want to have the whole council see it because it's so consequential. But I find it each time quite overwhelming because there's so many disciplines that you're listing in one report, and I've been thinking about whether we could communicate it in a different way. And one way I was going to suggest is that we anchor it in place, like we did with the Matahuru piece that we talked about in the previous item. Could we, Brent and Sutter and Gary, have a focus on, say, a TA or a constituency area and really understand what are the significant medium and lower, but still into topics for that area based on the state of the environment report, so that we can look at, like, if we are in that area, say for Hamilton, I know there's air quality issues and I know that there's some microplastic emerging and there's all these things, but I'd love to have them in context of and relative to each other, like we had on that Matahuru 2-pager of a scale. That way I could say, as a constituent representative of Hamilton, here is the biggest issue in my area from a state of the environment report perspective. And it really allows to ask that question, which is the one that kind of worries me, is if we're not doing enough in an area despite having the data. So that would allow that focus to come there. I realize we always do it per topic, like it's an air quality topic or it's a wood, but if you anchored it in place, I think we would comprehend it a bit better and ask the right questions about what we do about it, which comes to Jonathan's point about state pressure response. Yeah.
What
do you think of that?
collection?
That's
Is that possible?
Yeah, no, that's a really good suggestion. And in fact, I was talking to Michelle from RUD, who is around work engagement over clients and how they can communicate where the worst locations are within the region and what the main issues and pressures are, and whether we, through our state of environment reporting, could present it in a more pictorial, visual way. So with that sort of saying, well, in this area, these are the biggest issues. So we've sort of definitely agreed that's something we need to be better at with the report, and we've all visually comprehensive.
Okay, so this might help you even on the path towards that.
Yeah.
So maybe that would work for people.
Well, I think, because was one of the ones who said we should have a state of environment, so everywhere as wide as possible. When you gave me some stuff, I sent it all out to everywhere, because the state of environment from my perspective is that if the whole of the community is not understanding it and making it harder for our team to put some real good data together.
Yeah,
Yeah,
no
and
point writing the report if it doesn't get
yeah,
read
that's
kind of
exactly
thing.
right. It's a bit like the bus that we pay for doesn't go to Te Kuiti sort of thing.
Yeah. But like the human health focus, absolutely, they'll be interested.
We got
Thank
that,
you.
guys. Yeah.
What,
Ben.
sorry, just
Sorry. Go, Jonathan.
I was just going to add to that one of your recommendations last time was to also sort of really look at who was using the SOE report and how we and to try and help that in our design of the next stage of the report. So I think that's one thing we're looking at, and then and that was something we want to add as we can later this year. Who an organisation and who outside the organisation is using our SOA report, and is that being used in the best way? Is it in the best source of information to make their decision?
Good, thanks. Maybe we can be your beta testing.
Okay, who's next? Ben.
Thank you, Madam Chair.
Last one is Gary.
Two points. I like item 8 as potentially our next one, potential impacts of changing climate. Because of what you talked about, that stream in Parongia, you're going to be going back. So a lot of our catchment work never gets tested until you get the intent. It would be interesting to see, as soon as you've gone back, to get that data soon, so that we know is a 2 metre wide strip enough, the 5 metre. Because and I would also look at Karakia, because in 2023 we've had 2 major storms that have had major impact. So you can look at both, for example, in between Te Aroha and Pairoa, there was flooding for a week at a time. So major impacts. And then again, you've had the Parongia one recently. This is something that can feed into the way our whole system operates rather than just being a septic. So I'm speaking, thank you. And secondly, I would like to look at item 6, because I think that picks up Keith's point about mitigating adverse environmental effects but enabling growth. I think that's the balance that he was talking about. It's like, where can we go, where can we not? And finally, just on the geothermal, I hope that's going to pop up in the strategy, which central government.
Just thanks for that feedback, Ben. I think what I'll do is I'll have some conversations offline around the terms of reference of this committee and the terms of reference of ICM committee around the reporting back of the efficacy of the work that's happened in catchment space. We'll make sure it comes back somewhere. It's just about making sure it comes back to the committee with the right mandate.
I just think it has to be relevant. It shouldn't be where a stock bank is. That's all. You're talking about areas that had no protection around Parongia, so it should be in an area up near Matamata that's got no protection, not down in where there's stock banks.
So we'll take it offline and make sure it comes back to the right place.
It's all with what we do. Gary. Last one.
Like just 3 small quick points. Carbon credit farming, C to N ratio of pine trees. Keith raising that point about nitrates popping out of the woodwork and unexplained. Just, you got any comment on that? Like when pines are promoted to be put in for claiming carbon credits, yet the pines drop their leaves, drop their pine needles. Pine needles have a high, low, high, low carbon nitrogen ratio, and drop nitrates straight into waterways very, very quickly. So just comment on that for one. The other was your point about microplastics. Interested to hear that. I did quite a bit of work on that over the years. Whether that microplastics is identified as biooxidegradable plastics that can break down, but they are still plastics, but they go to such a small microscopic level that they can be absorbed by fish and then ingested by humans through eating fish and what have you, and animals. And the third is Lake Taupo. You said Taupo is in good condition. I question. Koi are now found in Taupo. They are catching them there, as Mikhail will fill you in on.
I'm not aware of that. Do you mean catfish?
No, koi.
Yeah, no, I'm not aware of that either, and
So,
Oliver.
McHale is aware of it, and they do
Yeah.
it, they do a catch each
So,
year.
so what we'll do then, and is
Yeah,
we'll
we can
look at
confirm
where
that, but
that
that
might
would
be
be,
in Lake Taupo without
that-
continue
yeah,
on.
that would be a
Yeah.
very, very, that would be high, that would be nationally significant. And we need,
Yeah.
we need
Yeah,
to
yeah.
provide
Yeah.
some evidence on
Yeah,
that.
well, McHale is the one to talk to on that. But the
No,
point,
we won't do that. We'll go and expect our team to go and have a look at it
Yeah.
because,
We'll
yeah,
dig into it, definitely. That's really important. If
Yeah.
that's the case, then
we have a problem because the
We have
last
a
time
major
I knew
problem.
there
Get
was
off
one,
the
they
game.
found
Yeah.
it and killed it.
now
Yeah.
the point that I'm
Yeah,
making
no,
is
so
that
keep going, yeah. Can
the
you?
point that I'm making is that fishermen in the lower Waikato that are catching them, catching koi down there, are finding that they are now full of whitebait. This year now, the whitebait season has been terrible. Whereas for the last 10 years up to it now, we've been having the best whitebait seasons for many decades. And before that, they were down low and there were all sorts of blaming there. So and then the line of questioning was whether they are also eating the albers, the eels, and also whether, if they are in Taupo, whether we are at Taupo now, where the Waikato was 30 years ago, and whether the trout are at risk there, and whether they're going to start stirring up the bottom of Taupo. That's just the question. So those three.
okay, thank
Yeah,
you.
you'll notice, take them on board
Yeah.
and go from there.
Yeah, apologies, I've got to go to a farmer meeting at Mangatagi.
No, that's.
But
That's good.
if I can take those points offline, Gary. I think absolutely important
Yep.
points you
And
raised.
come back to me and Brent.
I don't have a quick
right.
answer to the one about the pine CDN ratio or the microplastics, but I think it'd be important that we let our new microplastic scientist settle in, and then perhaps we can ask her some questions about that.
Okay.
Thank you.
In my case, ago, unfortunately. So
No, that's fine.
you're good.
Yeah, I'm
Yep.
good.
So thank you, Mike. Can I have a move and a seconder, please? Yeah, awesome. So we have one last, our last paper is with Ed. Due to the fact that our time is a little bit over, Ed has, is gonna come up and do what he needs to do as in a time span that we've asked him to do. Ka hara mai, Ed.
For context, you've just listened to the doctors. We're the phlebotomists. So my team is the experts that go out and gather the information, the data you're talking about. We think we know the answers as well, but we leave it to the doctor, even though they left the room. So obviously take. So the paper is read and it's focused around 4 monitoring goals that we have and monitoring techniques that we use. So this presentation will go through. The first goal is very much about you want to the right place, region, and you want monitoring at the right. And it's a bit of a balance, and you see in those 2 circles there the different techniques. So often if you do a lower frequency, such as we do with water quality, often monthly samples, we can do that in many sites. And then we can send the sample to the lab and get many parameters analyzed, easily 35. Heavy metals, nutrients, things relating to health. And it's with a high accuracy. So some of our sampling goes back 40 years at a location. We're able to compare those time and time again because of not just differences come in the instruments. More recently on the market, particularly for water quality, is high frequency monitoring. Which is awesome because it's giving you information every few minutes. But due to the cost of them and some sensors, you're looking at some sensors will do up to 6 parameters compared to the lab, which is 35. But if you're getting 6 parameters, you're in the order of $50,000 for an instrument. And then you're also running the risk because they're out there in the environment we described, which has floods and everything else. So it's open to a lot of antagonization. But yeah, fewer parameters. but the two work together. It's not one or the other. And examples of those. So just two examples here. So on the water quality side there, you can see we've got a network that covers much of the region, multiple points down multiple rivers, so we're able to see the change as you go down, and it gives us a really good base network. Compared to on the other side, the hydrology network, particularly flow, that's where we're using high frequency monitoring. So we're measuring river flows every 5 minutes. It's used for flood warning. We need decisions now, and we need that information back at council straight away for the flood team for decision making. And so there we use high-tech technology, but it's a bit simpler because we're often only measuring level. We're not measuring lots of different parameters. And so because of that, we tend to measure in less locations. There are constraints on that because in some parts of the region, you just can't measure, such as if you're in the tidal reaches, very difficult to measure river flow backwards and forward. So you can see there that sort of, if you do things infrequently, you can go to more places. And if it goes to the lab, you get high quality compared to high tech, costs more. So you choose your places carefully. Similar here, I'll skim over these times quick. Lots of the big yellow dots, that's where we go and do fisheries and invertebrates, similar to what Mike was talking about, the riparian surveys. We do those once a year. And there's a set time a year and it follows standards for everybody across the country. So it's a window between December and March. And you can only do it during low flows because you have to stand in the stream, kick the beard, get samples, things like that. But we do a quarter of those every year. And then on a rotation, the rest are done every 3 or 4 years. So we get that spatial spread, but not having to put resources everywhere. So we can achieve that with 2 staff, and then we get in some summer students who then support them. On the other side is the groundwater network. Similar approach, we have a real density, such as level monitoring around Pukekohe, because of high groundwater use, Tokeroa, parts of the Coromandel, when you're close to small coastal aquifers, only takes 1 consented take and it can put pressure on things, and trying to avoid saline intrusion. So a lot of monitoring focused around the high use areas. And then we add on top of that water quality and the groundwater, again focused around Pukekohe. There you have added monitoring beyond just the nutrients. So it might be things related to the chemicals that are put on for the horticulture. And what we're trying to do with the groundwater, and as talked about earlier in the other presentations, it's giving us that understanding of what's going to eventually come out in our rivers. So the change on your land use first shows up in your groundwater, and then will eventually propagate out your rivers. And then when you are at a location and you're there at the right time, as this chap is, you need to do it in the right way. So everything we do is following standards, and the National Environmental Monitoring Standards. All the councils have signed up to that. There's very few, if any, technology that you could, that concept of plug and play. You can't just grab something and it will go. The simplest one, even temperature, you need to calibrate because the electronic sensors start to change. When people think about turbidity, there is sensors now that do turbidity, but if you get a different make turbidity sensor, you can't compare the 2 results. And then if you're actually asking the question, I want to know about sediment going down the catchment, it's telling you about turbidity. It's sort of sending a signal out, it hits the matter in the water, reflects back, and it gives a number. We then have to go and take that manual sample from our water quality sites, where we're taking a sediment sample. If we take enough of those, match them to turbidity reading, you can then get a relationship between the 2. So then that's how those 2 systems complement each other through that sort of discrete manual sampling and this continuous sampling. So yeah, we're very fortunate, and all the councils come together and help develop these standards, and they're pushed from MFE, and we're all signed up through our CEs. Across the country, there's about 360 staff who do environmental monitoring. They come together through a Teams channel where we can communicate, and there's chats there around technology and different approaches and testing of instruments. So there's a real sharing, which is awesome. I'm fortunate at the moment because I'm the convener for that group, so I get the most gossip, I guess, or insights to things. We also get access to funding. So what you're seeing here are, I count, 1, 2, 3, 4, 5, 6, 7, 8, 8 reports that recently came out through EnviroLink funding, where we went through MB and got NIWA to write up guidance notes on a lot of the new technology that's coming out, because we want to do it right. But a lot of this technology is being deployed, then people are getting the data and then going, this doesn't make sense. Or they're also just losing the instruments when you're putting a big buoy out at sea and you haven't designed the anchor right. So that's a great resource which is coming together. So key point there, collaboration. This diagram, which comes out of those reports, you're starting off with the person on the side there on the far side from the boat. That's most of our sampling with those, where you're taking a water sample in a bottle, looking after it in the right way. You're choosing carefully how you take the sample because, yes, some of our sampling, if you take it right by the edge, that's where you get a lot of the, I'll just say it's crap, duck poo, weed, everything else rolling up. We're trying to get representative of the river. So people either with long special sampling sticks getting out 2 or 3 meters into the channel and trying to do it consistently each way. And that goes to the lab. So it's quite a simple process and low cost compared to as you go up the scale of bringing in more and more technology. It's giving you more information. It is great, but you're dealing with technology. So you need more skilled staff. You're getting, I did the numbers. So if we had a buoy sitting in one lake that was just measuring 5 parameters, would get over 8,000 data points back a day. And you have to manage those. So there's then going, what's the question we're trying to answer? Do I need 8,000 data points? Or could I handle, such as if we're looking at long-term changes from land use change, is a value once a month good enough because I'm seeing the direction of improvement or not? So really weighing that sort of, as you have in everything in life, that's balance between cost, technicality, and do we need that much information for the answer? One of the cool areas, and this is my heart, I'm a quantity, not quality person by training, but yeah, river flow. And so in the past, we're measuring river flow. We were always, staff would have been standing on that bridge. This is the Morco River, October last year. You can just see the nose of their vehicle up there on the edge of the photo. They've sent up a drone and they can use video imagery now that looks at the riverbed and you're seeing the blue lines and then under that are some red lines and it calculates the velocity. We do have to put some manual inputs in. So we've already been to that site because it is one of our flow sites. And the bottom graph there is the bed of the river. And so once you've got the bed of the river and you know the height of the water, you've got the area. So that's meters squared. And then you've got the velocity, meters per second. Bring the two together and we've got the discharge for that river. And they're also taking the manual measurements because we're training ourselves on this new technology, but we're able to calculate the discharge of that flow without putting staff in a difficult situation. In time, we're hoping to have cameras on posts at these sites. So we could be back at the office and just saying, please take a photo. The catch is a lot of our rivers are wide. So Auckland's doing this already, but there's politely, but a lot of them are culverts or drains or, so it's getting a camera that gets a nice wide lens when it's sitting on a post. But we're going in that direction. So this one we could definitely do from a drone. So that's probably the biggest advance recently that's come out in hydrology, and it's, yeah, a real game changer. Here's an example of like Waikari and the buoy that's on there. And as I touched on before, any data that we're collecting comes back to council, it's stored in our corporate database, and it has to be processed. And so even a water sample that's sent to the lab, we've taken manual samples ourselves, such as temperature and other things, and we have to match those to make sure it didn't get heated up in the lab and it followed the protocols. And then a lot of the electronic data coming in, such as rainfall and river flows, data coming in every 5 minutes. And this example here is for the hydrology area. We have a lot of automated processes where staff are auditing data and then they're telling other staff how they need to correct it. Notes are taken and then a quality code is put on it, and that comes from the NEMS. And so you can look at data. The highest code is Q600. That's awesome, great data. If you've got a Q200, you wouldn't use that in analysis. But you keep in the data, but such as if you wanted to ask a question of us, we wouldn't use the 200 data, because that's data which either there was an electronic sensor, it was covered in algae. So what we're actually measuring is the behavior of the algae if it's dissolved oxygen, not the river. So yeah, lots of auditing. The biggest thing that we've done a real push on in the last 7 years is data just can't sit in a council database. Got to get out there. This photo here is at Ngarawahia at our flood site, just doing repairs on the site. And so that's the tower there. And within the tower are all the measuring instruments, which measure, the water actually comes in via pipes horizontally, and then you're measuring down. On the side of it is the aerial, so that's for our telemetry, which is sending it back here to enable flood warning. So that's all about, we want the data now because we need it for decision making. And so we have an LTP KPI where we, for 97.5% of the time, have to have data available for decision making during a flood. And if it's green, which it is at the moment, we're meeting that KPI. So we're continuously using this KPI, but we don't just use it to say, phew, we made it. It gives us, challenges us to then, if a site isn't doing it, to see why. And it can be simple things, not quite in that photo, but if a tree grew up in front of that aerial over time or something like that, that can block the signal. It can be simple things like that. And so when that data is available, particularly for our flood team, this is just an image of a tool they get where they can get the hydrological information at their fingertips really quickly. What we do a wee bit beyond here is the black dots is where we work with our partner agencies. So the power companies, FENS, where we know they've got good accurate rainfall and we know we don't want to duplicate with sites there. So we do very little monitoring of rainfall and river flows in the upper Waikato catchment above Karapiro because Mercury's doing that with NIWA. So we have arrangements where we utilize their data. We can't always make that available to the public because it's there through a commercial arrangement, but it's available here for that flood management. But for the public, we have our Enviro Hub. And this is sort of I have a little joke, it would be nice if I didn't have to deal with the public, but in the concept, they shouldn't have to ask for data. They should just be able to get it. So this is the beginnings of our attempts at that. And so here you can go into such as the air quality if it was a topic, and there's nice, and I'll show you some for the hydrology, but we're trying to give the context for the public. So it's not for scientists or anybody else like that, but it's, yeah, so I'll just go into some of those. And so what you get in every situation is you're in a mapping area. You can see rainfall for this example, and you can see it either for the last day, 12 hours, last hour, right up to the last 30 days, which we're seeing there. So we're still seeing the darker blue, which is around the Waipa area and across the Coromandel where the high rainfall was. As you see, there's that gap there in the lower Waikato because we can't show that other private information we have, but we are working on some solutions there to see how we can fill those gaps. But as a start off, you can see the rainfall totals for your area and how it compares to the rest of the region. If you're interested in a rain gauge, you click on it and you get all the graphs on the other side. So it's got default rainfall based on each day for the last year. You can then zoom that down. I'm showing at the top there just the last 4 months. So we can see the higher total daily totals there for the February event. With context there for the monthly rainfall, because a lot of people are going, oh, last month was drier than normal or that sort of thing. And that's exactly what that middle plot's showing. So the black thin line across the middle, that's the normal rainfall you would expect in a month. And for this site out towards Porongia, you can see the first two tall bars are for January and February. And the first one is at 300% of normal. The next one's at 350% of normal. Now, when you're actually live in the system, you can hover over the top, you'll get the actual numbers, and there's toggles you can change to get more interactiveness. And then the rest of the bars you're seeing last year's data, but such as we're seeing the next low blue one. March was quite dry last year. When this March is complete, that graph will update. So it just keeps rolling through. And then the bottom graph there just shows the cumulativeness of the rainfall. It's another way of representing it, can be a bit quirky, but the imagination that if all the rainfall, you keep stacking up, see how tall it gets. So somewhere like on the top of the Fiordland, and people talk about like 8 meters of rainfall. Typically here across the Waikato, you're talking about 1,500 to 1,750 millimeters per year. So what we're seeing there is you've got the green line in the middle, which is how it would normally stack up. We've then put an envelope on that of the lowest it's ever stacked up and the highest it's ever stacked up. And then we've just put on this year. And as you can see, the February event caused us to be at a new record for this time of year. It went straight up, and then we haven't had rain for the last wee while. And when I did this graph, it's a bit hard to see, but under the top, there's a little information saying how many days since the last rainfall. I took that one because a friend of mine who's farming, we play tennis together, and one of his conversations every night when we play tennis is, oh, it's been, feels like a month since it rained. And I'm like, really? So I added this, how many days since it rained last? And similar here for river flows, people can get information on river flows. This one, you can change the map a lot more. So if you're interested, river levels, this is set at how are we in relation to the flood level? And so at the moment it's showing negative levels. So we're typically, say in the Waipa, 5 meters below the flood levels at the moment. But then you can see the hydrograph for the site and a similar plot down the bottom showing how the hydrograph compares to all the other years of record. The biggest thing to take from that bottom plot, which I like, the green line is showing the average flow, what you typically get. So you see your summer recession at the beginning, it's just a low flat river, and then you get your winter highs. But when you look at the top line, you can see at any month, at any time of year, you have floods. So over its history of at the site maybe is 40 years. So it brings all that contextual information, and then you the other place we go is Lawa. So here's the safe swim. So every week during summer, students go out and get a coli samples. They go up onto Lawa, and then you can see, based on the most recent site, if it's a good to swim. Conversations that were earlier, particularly about phosphorus. So you can go into Lawa for all our monthly water quality results, and that's what this graph here is showing, which is just by chance, good question, that was earlier. And so it's showing if it's good or bad by color based on some bands, but it also puts inside those dots that are a bit small to see, but an arrow. So if the arrow is going up, it's improving. If the arrow is going down, it's getting worse. And so for a lot of these sites, it is showing improvement when looking at the last 10 years. And so anybody can go into this Lawa, play around on any of the parameters that we're measuring and compare it for our region across the country, or on the other side, showing it there just for the Waikato catchment. So you can get real contextual information. You can get this information for the invertebrates and the fishery samples and other bits of information that we're monitoring. And then part of the paper was around opportunities. Things are we taking up? So the one I'd like to see is that there is new technology coming along in E. coli, really expensive at the moment. I think it's the last ballpark's like 50K for a sensor to measure E. coli. But it's very new, so the price will come down. But eventually to get a small number of those out there, so we've got continuous E. coli at a swimming site, rather than a weekly sample, and then you have a rainfall event, that totally change the result. So to get that relevancy really going, it's a bit like the flood warning. You actually want decision-making much more quickly. And the other one, the lake sampling, where that chap was out in the boat, there was another person there. It's a real pain to get to our lakes. You're often carrying a boat, dragging it across the grass, getting out there, lots of conditions. If we could have not so much a drone boat that then go out and sample. So there has been some toying around with different people in that technology space. We haven't got there yet, but that would save a lot of labor and resources. One thing we don't have, but I've heard about, I haven't actually operation, samplers which are float, continuous samplers, and they just float down the river. They may be more useful, not so much in our state of the environment, but more for the incident response, where you're trying to find where something's entered a river. And you've got good water quality up here, poor here. Where is the point where it's changed? So something that can float down. Yeah, and those are just some of the areas that we're focusing on. Sorry, there was a bit of a whirlwind.
Who's first? Harry.
Well done, Ed. Just a question there, turbidity. Do you have data on the turbidity between Waikiri, Wangapai, Waikato River, Waipa River, Maramura River, Mangatawhiri River? Just those, specifically those, and the comparisons and the timeline of whether there's been a change in those rivers and whether they're similar.
We do have data, but most of it's quite new. So recently we're deploying one buoy that will have all those sensors. So it's not out there yet, and that's the deal with the black water events and the fish kills. For the ICM consents, there is turbidity monitoring. I haven't looked at that data because it's been contracted out, and that was one of the things where we've now bought that in-house for a significant saving. So I'd need to look at that because we only just started last month. But what I'm looking at is, because science is wanting to learn more about parts of the catchment, ICM doing the rest, by bringing it in-house, I want to get the instruments common so that we'd answer exactly those questions. At the moment, I know some of the instruments are different. So the turbidity readings, even if calibrated and correct, aren't like, it's not apples with apples.
The reason I specifically ask is the turbidity tied in with PC1 and not just the Whangamarino, but all of the other catchments, whether they are all elevated at the same time. That's what I'm thinking for.
And so
just with an open mind, just to see.
No, sorry, it is in our business plan of where we see an opportunity in that lower Waikato catchment to get a better network, and but we wouldn't have historical data for your questions. Setting something up going forward. There is data from the ICM, but it may not answer quite well. Absolutely agree, that's a hotspot.
Could we go back a couple of slides?
Here you go back. Oh, he's some. Yeah, no,
Next one. Next one. That one. Two things. So one, we talked to Mike Scarsbrook about what comes up for the next EPC, and one of the issues was climate and its impacts and flooding. It would be helpful to have some of these graphs in your presentation with him, because that clearly shows where the flood peaks are in 2023. Secondly, you talked about gaps in the data. Is that because they've been contracted out?
You mean in physical location?
On the map.
So this been
Not necessarily that map, but the earlier map.
Some of them. So some of them we choose not to do there because we know there's other agencies. So we haven't contracted it. Very little of our work is contracted out.
Okay.
Air quality we've contracted out because it was only a half FTE and it was hard to keep the excellence and the skill that was needed.
Right.
So we don't contract out the hydrology or water quality, but any gaps is because we're using other existing agencies.
So item 34 on opportunities for saving, you have reduced expenditure by 100,000 a year because you brought ICM continuous monitoring in. You want to explain that? And
so that's
your procurement processes?
So that was consent required monitoring, as any consent holder would have. And ICM has conditions about monitoring turbidity and other water quality parameters. Had been contracted out, and we put forward a case that I believe in the annual plan came to council showing the savings because we could do it in the house. So that data is data that wouldn't have in the past shown up on this public facing information, but now it's under environmental monitoring, all into our systems, our data integrity, and will eventually. So it's more of a, we never contracted that out. That was a ICM consent.
Right.
And I think a historical feeling where a split in the council was needed. If it's then going up to RUD for compliance monitoring.
But 100K is quite a significant
saving. No, it's great. No, it's fantastic.
In the map you've got on page 31, you show your environmental monitoring, hydrology, water quality, ecology, and data. I anticipate the hydrology stuff all goes back through the emergency management team. Is that their data about where you've got flows, or does it all come through you?
It all comes through us. And so the same as, so we feed through to the emergency team, but as a customer.
But you're responsible for making sure that the buoys are in the water and the. Okay.
And the hydrology is quite a bit wider than just the emergency as well. There's other.
Right. When are you looking to get the drone boat?
So someone did make a demo with like a kayak and a winch and things at the front. One of the difficulties with lakes compared to rivers where you largely scoop from only a short depth, lakes, if you have to measure the temperature all the way down because they have different layering.
Right.
And so depending on the layering of that day, you then have to take the sample from the right depth.
Right.
Get depth and from the middle of the lake. But Right. So it's we don't have large research funds, so we use there's the emerging technology project in the spatial team. So we there's a person there who's good with drones, so we try and feed projects through that. But they tend to be a slightly bit of a slow burner hobby when someone's got a great idea.
Right. You've also talked about the buoy in the lake has 8,000 data points per day. You seem to imply that the data points are almost overwhelming. You've got too much information.
Depending on your question. So for instance, plan change 1 was a topic. And if you're looking at, are we meeting targets towards our 20 or 50 or 80 year targets? That's where 8,000 data points a day, because there's a lot of noise in those data points and a lot of managing of them. And sometimes the instruments, just because they're electronics, will have spikes because of a lack of earthing or lightning or, yeah, so you've got to tidy it all up. Where monthly data for plane change 1 tells you a whole story on that long-term behavior. But if you are asking about turbidity events due to a rainfall event, then we need that continuous monitoring. And so that's where it's worthwhile. But you'd maybe only run that for a year or two.
And
part of
how
your long term.
much is AI going to help you with the data analysis? And are you
Yeah.
seeing a rapid increase there?
Not in the processing yet. And so one of the reports that was done by the external funding was to look at data anomaly detection, so using automated tools. At the moment, they're all university level, where if you've got a person who's built the software and then they're loading it in, it seems to work. As soon as you throw something else in or some other operator,
Right.
So we're definitely watching and we're keen. Yeah.
And finally, with your environmental DNA data, testing is underway to improve the time-consuming process of field filtering. This will save considerable frustration from numerous breakages of sampling syringes. Do you want to explain that?
So when you take an eDNA sample, it's pretty much a syringe of that sort of, but inside of these filters, and our rivers are not as clean, so you're bringing through a lot of sediment and you're trying to pull the syringe back. And then when you've got it in, you then have to push it down, and that's the pushing down when you've got this, the plastic just snaps. And so they're trying different pumps and hawking guns like you use for doing DIY and
So
So they'll
not an
often
easy
be able,
process.
yeah.
Okay.
So eDNA is not like water quality chemistry where you can just scoop a sample and it has to go through particular filters in the field and in the process, and that takes a bit of time.
Thank you.
Thanks, Madam Chair.
Francine.
Thanks, Ed, for your presentation, and I'm overwhelmed with data now. There's two things. Are we collecting too much data? Because I remember having a discussion with Mike Scarsbury ages ago saying they can't process this data. So obviously that's a cost. So if you can answer that one, and I've got the other question coming.
Yeah, I'd say no, but everything's up for a debate. My colleagues harass me that our rainfall network isn't dense enough and we should have more rain gauges. And so if you look at a national map, we have a very low density. But that's because I'm relying on other parties through agreements where there's no cost or anything. Water quality, we have one of the most comprehensive networks, but then we're hearing questions. So can you tell me if it's this subcatchment or that subcatchment? So if we were to then downscale just to doing, say, under the National Policy Statement Freshwater Management, they talk about FMUs. I know that will change, but if we just went, let's just do catchments into big chunks, everybody then says, but that doesn't relate to my catchment or my farm. So if anything, we get more public pressure. Why don't we have a denser network? Yes, that costs at a balance mix. So I think it depends on your problem at the time and the questions you're getting asked and the pressure upon you.
Okay, so thanks for that. The other question, Ed, is you say the data's all free if you're allowed to get it.
You're allowed to get it. No ifs.
But my question is, have you looked at commercializing, selling the data? Because I'll give you the example of my situation. I have a river at the back of my place which floods. Through contacts through ICM and that, I can get very, very good data when that water is going to arrive, and sometimes it's 2 days later after the thing. And if I could get that sent to me by text or by email, I pay for that. So it's a management thing, and so it's not only that. I'm looking at spending $2,500 on a rain, automatic rain gauge. Well, if you can give me that data on a regular basis, that's valuable to me. Also, if you can give me the water quality, that's good to me too, because we're talking about PC1 and Timana O2Y and all that sort of thing. that's really valuable information for us to monitor what's going on. So I'm happy to pay for it if you guys are prepared to start commercializing and give me a service.
My understanding, and I need a lawyer to back me up, but I understand that legally we're not allowed to charge for the data that we gather, which has come from ratepayer. But if you ask for a wealth of data where I had to spend a lot of time extracting it from a database, I could charge for the time to do the request so much. So possibly if you're after a text service, we might go, that's an added, possibly there is a little charge there. We don't at the moment. So for our flood network, people can just get their phone number added to a system. They'll get automated text so they know when to move stock and do other. But I believe we're quite constrained on how we charge. But I think we will be more imaginative when the National Environments Bill comes in, because at the moment we get a third of our funding from consent holders through either doing an activity that results in needing for monitoring, or they benefit from the information. There'll be less consents, and there may also be, there doesn't seem to be the same Section 36 funding opportunity that I've seen in the new bill. So that would then land more monitoring just onto the general rate.
So I guess the answer to that is no, it's not commercial, but is there somewhere people can access your data, because that's what data is all about. It's about to be accessed.
100%, yes.
Yeah,
So this screen here is on our website.
So I don't know how much of that will help, but that's something that's it's not happening at the moment, Keith. It's not commercialized, but data is available in lots of different areas, lava, EM, all of them, and maybe from us as well, if you request something.
I think
Maybe
Katarina, it's people like me are time poor, and I don't like digging in the garden looking for a potato. But if you send me one by Uber Eats, it's a lot easier, and I'm prepared to pay for it.
Absolutely.
Yeah.
Jen? Yeah.
Thanks. Yeah. no,
Last one's Robbie.
I
We're gonna
wonder
close
if
that,
it's
Robbie.
us or somebody else who wants to use our free quotation data to provide a service of
And that occurs through NIWA, for instance. They'll take our data, possibly build some product out of it, and then turn that into a commercial. But they're not so much selling the data; it's the commercial tool.
It's the convenient
to do
and
something.
such. Have you done any costing on using a drone versus the boat? I've gone out on the boat. It is very labor intensive.
Yeah.
Have you costed how much you'd save each trip and across the network if you did have the drone? I just wonder.
Yeah, not so much for the drone. We haven't costed that out.
No,
Really
I mean
depends on the
purely for not
technology.
having to use a boat.
Yeah, but for instance, we do, staff have done costings. For instance, we would often use a helicopter to get up to the Pinnacles, Rangage and Golden Cross. Fortunately, I've got some younger staff member and they worked out it was cheaper for them to run up. So they're now running up.
I love it.
And so
Love it.
they did the cost analysis, and they, even with their hours and their time, and they're keen to do that. As they age, we may have to bring the helicopter back. But
Or hire more people, hire somebody else.
Yeah.
Okay. Thank you.
Yeah, but no, we do look at all those concepts.
Closing question, Bobby.
I know, I'm just a little bit supportive of Keith here at the moment, where I think if we want to do good weather predictions, like the situations when we had down the Waipa River the other day, that we were actually giving data to NIWA that they weren't even collecting, and we got landowners that are prepared to pay for that, I think we maybe think about making a little CCO to make a little money on the side or something.
Well, you go for it, Bobby, and let us know so that Keith will know where to go to buy the stuff.
Yeah.
Hepai? Okay, so thank you, Ed. Thank you, Ed. Mover and the seconder, please.
Yep.
Yeah, awesome. And we'll close with a karakia. No closing comments. We'll close with a karakia, and thank everybody for being here. And I'm not apologizing for the time because you guys had some long, extended questions, but I will have a chat to my mate about the summarization of their things, okay? But blame them for making so many questions. Okay, karakia.
Unahia mai turi tapanui. Kia wātia, kia māma, te nākau, te tinana, te hinengaro. Te ara takatū, ko rāhi rongo, I whakāria aki ki runga. Kia tīna, haumie, huie, tai ki e.
Thank you, everybody.